Good morning. Today we're going to do Chapter 10, Section 5, Rotation of Conics. We classify conics by using the discriminant. And the standard form for a conic is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And if the discriminant is less than 0, it's an ellipse. If it's equal to 0, it's a parabola. And if it's greater than 0, it is a hyperbola. So, first example, identify the conic and find the rotation angle. So we do our B is equal to 1 and A is equal to 0 and C is equal to 0. So I have 1 squared minus 4 times 0 times 0, and that is equal to 1. Since that is greater than 0, this is a hyperbola. Okay. Next we need to find the rotation angle, and we do that by using cotangent of 2 theta equals A minus C, and we already know that A is 0 and C is 0 over B, and B is 1. So cotangent of 2 theta equals 0. Well, that's going to be where 2 theta is equal to pi over 2, because that's where the cotangent is 0, which means that when I divide by 2 or multiply by 1/2, theta equals pi over 4, which is our rotation, and we can also say that that is theta equals 45 degrees. Again, we want to classify the conic and find the degree of rotation. So in this case, A equals 5, B equals negative 2, and C equals 5. So that's negative 2 squared minus 4 times 5 times 5, which is equal to 4 minus 100, which is negative 96, which is less than 0, which means we have an ellipse. Okay, now to find the angle, cotangent of 2 theta is equal to 5 minus 5 over 2, which is equal to 0. So 2 theta, as we know from the previous problem, is equal to pi over 2, and theta equals pi over 4, or theta equals 45 degrees. This is a little longer equation, but we still only need to pick out A, B, and C. A equals 4, B equals 4, and C equals 1. So that's going to be B squared, 4 squared minus 4 times 4 times 1. So that's going to be 16 minus 16, which equals 0. That means it is a parabola. Okay, then we know that 2 theta is equal to the cotangent we know that cotangent of 2 theta is equal to 4 minus 1 over 4, which is equal to 3/4. Okay, so 2 theta equals the cotangent inverse of 3/4. Okay, this one is not in our calculator, so we're going to have to, not on our unit circle, so we're going to have to use our calculator. So we need to get it into calculator ready information, so that's cotangent inverse of 3/4 divided by 2. And theta equals 26.6 degrees. On this problem, we're going to use the discriminant to classify the graph and use the quadratic formula to solve for y. So again, we pull out a, b, and c. A equals 2, b equals 4, and c equals 5. So that gives us 4 squared minus 4 times 2 times 5, which is 16 minus 40. And that's negative 24, which is less than 0, which makes it an ellipse. Now to solve for y, we have to do something a little different. We have to put it in order with the y squared term first, so that's 5y squared. Then we put the xy and the y term, so that's plus 4xy minus 4y. And then we put everything else, which is the plus 2x squared plus the 3x minus 20 equals 0. Okay, that makes my b, well, first I need to simplify it, so that's going to be 5y squared plus 4x minus 4y plus 2x squared plus 3x minus 20 equals 0. Okay, so I plug in y equals negative 4x minus 4 plus or minus the square root of 4x minus 4 squared minus 4 times 5 times 2x squared minus 3x minus 20, all over 2 times 5. Okay, and the only thing we need to simplify is the 4 times 5, so that's y equals negative 4x minus 4 plus or minus the square root of 4x minus 4 squared minus 20 times 2x squared minus 3x minus 20, all over 10. Okay, that's it. Bye for now. That's all, folks.